Hey, hello everyone. Welcome to this session from free conference call. So this SDE skills, this is supposed to be the programming interviews easy session. Unfortunately, I hadn't actually had a whole lot of time to prepare. So what I did was I cheated and reused the Leetcode that we have going every week, and I have used those questions for this one. So what we will do today is I have 3 questions. And we'll just walk through this. Just in case for folks who have actually heard about us through different forums and you're getting in this session differently. SDE Skills is essentially a 501c3 nonprofit organization. We've been essentially in operations from 2010. It was actually formally set up in 2017. We are pretty much committed to working with the local community here in Seattle East Side area and online community as well to help grow engineering talent and to make sure that we get the engineers the skill that they need to be successful at programming interviews. So we do a whole bunch of activities and exercises. So strongly recommend all of you to join the SDE Skills Slack, number 3 in the bullet point, which is sdeskills.com/Slack. We actually have a pretty vibrant group there. We discuss a whole bunch of questions. And we also have like a weekly Leetcode question that gets posted by the Leet bot. And we're just picking the questions that were posted for this week, for this discussion. So without further ado, let's jump right in. I see a bunch of folks here. So first question. This is a very simple question. The first question is essentially given an input string, check if they have valid parentheses. And this question is like super straightforward. Essentially what you're trying to do is it's a matched parenthesis setup. So if you have, and you can have an open round brackets or the curly braces or the square bracket, you just have to make sure that the right brackets are in the right order. Any recommendations as to how we should go about doing this? Anyone?
Hi, this is Sunita here. So I was thinking of like a stack, using a stack, maybe pushing in the open parenthesis, and once you encounter a closed parenthesis to pop it.
Okay, that sounds logical. And so every time you encounter a closed parenthesis, you pop the element, and what do you do with the pop?
Then we know, like when the pop returns, like in its fine, then we return the output. We need to return as the true in this case.
So you're missing one step in between, right?
Yeah, we go through the whole string. And
no, go through the whole string. Every time you encounter an open parenthesis, you do nothing. You just push it into the stack. So far, so good.
Yeah.
Every time you encounter a closed parenthesis, you pop from the stack, and then what do you do?
Maybe I have not thought through this problem, but I have a counter for the like number of pushes equal to the number of pops, like that. Make sure that all the parentheses, everything. Is,
no. A couple of. So let's walk through this.
I believe like we can check like 2 things. Okay, we can check like 2 things. If once like we're getting the closed parenthesis, like either of the 3, we can check if a stack is already empty, then we can simply return false. Cause like if a stack is empty and we are still encountering the closed parenthesis, that means like a string is not valid. Otherwise, like we just pop the top one, and we just match it with the incoming closed parenthesis. So if it is like curly braces, like closed curly braces coming in, the top element should be open curly braces. If it is square braces coming in, the closed one, then the top one should be open square braces, and that way like we can make sure the string is valid.
Correct. So if I were to re-summarize what you just said, I've typed it. In case you guys are following along on screen, it's line 36 to 40. If you're following it up in the Slack, in the Etherpad, then it is like just go there and you can see that as well. So if we get an open parenthesis, just push it to stack, don't think about it. If you get a closed parenthesis, then check if the stack is empty, because if the stack is empty, then obviously it's not good, so you return false. If the closed parenthesis is there and then you pop the top one, you can only do that if the stack is not empty. And then you try to match what you popped, because what you popped was the last open item, right? The last open that was put in the stack. So the closed parenthesis has to be a corresponding matched pair. So open round braces has to match the closed round braces. Open square bracket has to match the closed square brackets. If the match is not true, then you return false right away, right? Otherwise, then once you're done with the whole string, what do you expect? You expect the stack to be empty. If the stack is not empty, that means that you have a few unmatched parentheses available. Very simple, right? Any questions?
I guess you would have to check to see if the stack is empty. Like, what if the first index in the string is a closed parenthesis?
Then it will fail number 37.
Okay.
Because you get a closed parenthesis and then the stack will be empty, so you return false.
So would that be O of n runtime and O of n space?
Technically, it will be technically it should be O of n by 2 space.
Okay.
But yeah, it's still O of n, right? Worst case scenario, in the real worst case, when you have, like, let's assume that for all practical purposes, space complexity is measured in order of n square and so on. So the constants generally don't matter, right? Mm-hmm. So if it's O of n or O of n by 2 or O of 2n, they're all still considered O of n. But let's assume that you are super, like, this is supposed to run in some sort of, like, ultra low memory system, and you were really, very crazy about whether it is n or n by 2. Okay. Then you could actually have an additional check that says that you process the first, at any point of time, if the number of letters that you're trying to process further, right? So if you have, let's say you have processed k elements, k characters at this point of time, and your stack size is actually greater than n minus k, then you're done, right?
Yeah.
Somebody's pinged. Somebody's trying to join the audio bridge. Okay, then I have to figure out. All right, so that's what it. So you could do that as well, but this check is actually superfluous. It won't really help a whole lot. I mean, in the sense that the worst case complexity doesn't change of sorts, and then it just doesn't help a whole lot. But it's something for you to think about. Okay. Now let me ask a slightly different question. Like, what if I am able to tolerate like one mismatch? Like, one thing can be mismatched, but not more than that. It's not like a perfectly matched. So this question is to match perfect parenthesis. But what if I said that you had the power to insert one character anywhere if you want to fix it?
So the question is like missing character or like invalid character?
Not an invalid character. So it's just just parenthesis, open, close, square bracket, curly braces, all of that. That's all. That's the question. But the question is that you are permitted one error, one mistake, which means that this is a valid, like just open parenthesis is a valid one. Okay? Like if I have two opens and one closed, that's valid.
I see. I guess you can use two variables.
Mm-hmm. And how do you do that?
I have one variable for open parentheses, one for close, and then you can...
Before you go any further, like let me just take a step back. So are folks clear with the question?
I think we have to go with the stack, whether the stack count is 1. If the stack count is 1, we will be having this one element in the stack.
That is but that would work for this case, but however it will not work for this particular scenario.
Yeah,
where I have it's open bracket, square bracket, and close bracket. This is also valid. Line 32 is also valid. Does the question make sense? Mary, I think you're answering something which is, it's a slightly different question.
Yeah, it's a different thing because
yeah.
I didn't know we were counting the brackets. I thought we were just counting the parentheses still.
Yeah. It's all of them, brackets, parentheses, and the curly braces as well. So,
okay.
So this is a valid string in that case because you have permitted one mistake. So which means that I can either delete the square bracket or I can add a square here and then I'm still good. It's actually not a whole lot different from what you just saw.
So what we have to see if there is odd number of elements in the string, and then we can traverse through it to see what is missing.
Yeah, but the odd number is not, that's not a guaranteed, that check is not as effective or as efficient, right? So I think we had one, like I think Raj someone was saying that you should just go through the same approach, and let's assume that if you're done with the string and you expect the stack to be empty, but not in this case, you may expect the stack to have one element, and then you're good. And that works if the issue was actually the first bracket, which is unmatched, and everything else after that was matched, it will work. So that kind of works. However, the thing is that what you should be doing is you are permitted one error, right? You're permitted one mistake. So you have a Boolean variable that essentially says something like that, right? Mistake found is false. Okay, so when this happens, like when you get an open parenthesis, you push to stack. You continue doing that. If you get a close parenthesis and stack is empty, then you return false. Not really. If you get a close parenthesis and then you if you get a close parenthesis and then you actually have your stack is empty, then and your mistake has not been found, then this is the mistake, right? So you don't return false. You essentially, if mistake found is false so far, then you just set mistake found is true, right? And if mistake found is already true, then you return that false, saying that then you return the thing is invalid because now you found two mistakes. Okay, and then so that's easy. The empty one is actually the easy one. What do you do when you actually find you get an open parenthesis and you get the close parenthesis, but it's a mismatch? What do you do? It could be either, right? You could actually, so if it's a mismatch, then it could be one of the two things, right? It could be a scenario like this, or it could be a scenario like this.
I believe like it should be the same. Like we can still keep the use of the same Boolean variable. Once like we find the
not really. Boolean is good, but what do you do with the pop?
Just simply pop it and set that Boolean to true. That okay, like we already found one mismatch, and then we are continuing.
Yeah, but what is in line 34 will fail. Line 34 is true.
Yes.
We have to do another pop to make sure the next element matches. With the Boolean, we will see like, okay, the first one is, we have already reached the mistake found equal to true, and then do another pop if it is true, and then make sure that it is like the next string matches, so that we can able to continue.
Correct. Fantastic. That's all. It's a very subtle thing. So the thing is that if it's scenario which is like line 32 scenario, then what you do is that you take the pop and you discard the pop, but you still keep the close parenthesis, right? That's what you need to do. Okay. Or the other scenario is essentially what you do is that you don't pop, you just discard the parenthesis. So you have to do one of the two things, right? You either, so in this case, in 44, when that happens, you either discard the pop or discard the close parent. Where's this message coming from? I think is it Slack? Oh, that's somebody's actually on the chat, is it? Okay. Streamed on YouTube. You have to use the phone bridge or okay. All right. So that makes sense, right? So far so good. So this is it for this question. So this question is not very complicated. It's a very simple question. But what I wanted to hear was what I wanted to actually talk about was that how you can take a simple question and make it a little bit more complicated or a little bit more like nuances and complexities there. All right, so let's close that and let's jump to question number 2. Any challenges on question number 1? I don't want to spend any more time than this. All right, let's jump to question number 2 then. Thanks for playing along. Question number 2 is, what is the minimum number of moves to make an element, all the elements of an array equal? So essentially the question is like so. Let's open Leetcode and see what it is. So if your input is 1, 2, and 3, how can you make all the elements? How can you make all the elements 2? You can subtract 1. You can add 1 to 1, and you can subtract 1 from 3, and net of it is that you have 3, right? So you have like 2 values, and in 2 moves you can make it happen. So how do you what is the most logical way of actually making an array which is like 3, 4, 7, 8, 9, 10 to a same number? How do you do that? What do you think? Any thoughts?
I think we can travel on both the sides.
No.
Maybe we can.
Yeah, go ahead.
Yeah, we can check XOR of 2 numbers and see how many such disconnects are there, and just replace that count with that particular number.
No, here the goal is not. It's not binary thing, right? So essentially, what you need to do is you need to let's assume that you want to make all of this 1, right? So what you need to do is nothing. You don't have to do anything to this. How do you make 2 1? You subtract 1. How do you make 3 1? You subtract 2. How do you make 4 1? Subtract 3. Subtract 6. Subtract 7. Subtract 8 and subtract 9. So essentially the final answer, if you want to make everything 1, is essentially the addition of all of these things. So it's essentially 1 plus 2 plus 3 plus 6 plus 7 plus 8 plus 9, which is 36. Okay.
Maybe
but
the average.
Average. That's a good choice. So let's do this, right? So we can bring it to close to the average, and let's see if that makes a difference. So the the sum of all of these numbers, right, is essentially 44, and there are 1, 2, 3, 4, 5, 6, 7, 8 numbers here. So if I divide by 8, I get 5.5. Okay. So I can either make it 5 or either I can make it 6. Okay. So intuitively, average is what I thought as well when I first looked at this question. And there are a few concerns with this, but let's actually go figure it out. Okay. So how do you deal with this? So in order to make something 5, so this will essentially be 4 plus 3 plus 2 plus 1 plus 7 becomes 5 if I subtract 2, 8 becomes 5 if I subtract 3, 9 becomes 5 if I subtract 4, and 5, right? And that is 24. On the other hand, if I make it 6, right, 5, and this becomes 4, and this becomes 3, this becomes 2, this becomes 1, this becomes 2, this becomes 3, and this becomes 4. And this is also 24. As luck would have it, they both actually give you the same value. Okay. Is there a better answer? Just for kicks, I'm just going to add a 0 in the front. Okay. So that essentially will make it 5 plus and 6 plus. Right. At this point, it's 44 by 9, so it's 4.8. And just to make it a little better, let me actually make it a 1, so that's 45. Okay, so it's 45 by 9, that is 5. So there is no randomization, so this is it, right? So this is 28. Do you think there's a better answer?
So this array is sorted, right?
Yeah.
Always? Okay.
No,
so
not necessarily sorted, but let's assume it's sorted.
Okay. So how about picking the middle one rather than doing average distribution?
Yeah, let's do the median, right? Let's try the median. The median is 4, right? The median of this is 4. So if you pick median, then it's 3 plus 3 plus 2 plus 1 plus 0 plus 7 becomes 3, 8 becomes 4, 9 becomes 5, and 10 becomes 6. Right? And that's 27.
Yeah, not that bad, much better.
But not a whole lot better, but a little better, right? So the question is, would you do the average or would you do the median? Clearly, median is working better than average. Why?
Depends on the data set, right? Because if there are extremes, then probably average would be distorted.
Let's find out. Okay, let's do this, okay? Now what do you think? Let's say we have 1 million zeros, okay? Or like whatever, 999,999 zeros, and one number is 1 million. The average is 1, right?
Yeah.
And if you want to make all of these things 1, then what do you get? You get 999 times 1 plus 999. This is what you get. Right?
So
Which is almost
repetitions like that, then probably mode will be the accurate one.
No, not mode. Not really mode. It's still median. This is essentially almost 2 million. Whereas if you actually
average 1,
because there are 1 million zeros, like our 999 zeros.
Oh, okay.
Followed by 1 million. That's it. Just one number, 1 million.
Okay.
So there are 1 million elements, right? 1 million elements. 1 million is the total sum. So the average is 1, right? Okay. Whereas if you do this is the average model. Whereas if you do the median, then that's 0. And what do you get? It's just 1 million. That's it.
Median is better.
In this case. In this case. Okay. Any other? Anybody wants to try a different scenario? Like how would if this was asked in an interview, how would you know which one to pick? Like, I understand, I know 3 concepts. I know median, average, and mode, and I can create data sets like slightly obscure ones and see that median is kind of performing better than average in some of the examples that I saw. And I have not yet figured out an example of where average is performing better than median. Equal, I think we have seen a few scenarios based on my previous examples, but not here. But I think I can think of that. But I've almost always seen median outperform average. Mode is the other concept, but mode may not be the right thing because mode represents the most repeating element. The mode actually works better if the cost is not measured by the deviation, but the cost is measured by how many distinct numbers do you have to change, then I may have a reason to say don't change the, like, find a way to not change the most number of numbers, right? Then it's okay. But since we are looking at the distance covered, it might make sense. So there's actually a mathematical proof for this as well, for the median. If you look at the discussion, they'll actually talk about why it should be a median, because technically speaking, your goal is essentially to go, you have like essentially you have a minimum number, and then you have a bunch of numbers, and then you have a maximum number, right? And your goal is essentially to take it to a constant value somewhere in between, correct? So you have n elements total, okay, and you are trying to get to a constant element c that's in between, okay. Now here's what it is. What does it take to go from min to c? It's essentially c minus min, correct? What does it go from max to c? It's max minus c. What is the total cost of both operations together? It's max minus min. This is addition of these two, right? Okay. So if you have n elements where there is a max element, there's a min element followed by n minus 2 elements followed by max element, then the cost, the best way of actually bringing it to a closer number is the same as whatever is the best way to bring n minus 2. Solve for n minus 2.
Okay, yeah.
Right? Because whatever that number is, whatever that c is, whether c is actually somewhere in between mn and mx, right? It doesn't have to be anything. Then the problem is the same. So what we're saying is that at the end of the day, if you keep taking away both the extremes and you keep repeating this problem, ultimately you'll be left with only one number, and that is a median. Or you'll be left with two numbers. If you're left with two numbers, then either of them is the answer, or something in between as well, doesn't matter. Any number between the two values, right, of the median will be the answer as well, because the cost of transferring will be identical. Does that make sense? That is why this is median. So it's a little bit, it moves away from a programming exercise to a math exercise. But any questions? Any questions? All right. So so now how do you figure out the median of a data set? Now that the question is actually simplified, to find the median of a given data set, it is not sorted. Okay. If it is sorted, it's simple. Just go bang smack in the middle, you're done. But if it's not sorted, then how do you do? How do you figure out the median of a given data set?
Sort it first and then.
What is the time complexity of sorting?
N log n.
N log n.
Yeah.
N log n. Can you do better than that?
Can you use 2 pointers to go through?
But no, it's not sorted yet, right? The data set is random. It's in a random order, so it's not in the same order. So let me ask you a different question. Given a data set, how do you find the smallest number in the data set? Would you still sort it?
No, we can just traverse it once and keep saving the minimum as we encounter.
Exactly, right? What if I have to find the second smallest number?
We can do it in the same iteration.
Correct. Now, in one iteration you can probably do it, maybe 2 iterations, because in one iteration you can find the smallest number, in the second iteration you can probably
the length of the array.
Yeah, or you can figure out how to do that. Now, have you heard of this thing of, like, given a data set of n elements, find the k smallest elements? How do you do that?
Quick select algorithm.
Quick select algorithm, exactly. So the best way to actually find the median number, or like the number that actually represents the median, is essentially find the kth largest number in the array, or find the k where k is n by 2, and you can use quick select for that. And for folks who do not know what quick select algorithm is, there's a bunch of videos on YouTube about quick select, and what you should do is that you can actually use go to YouTube and look for it. But let's actually quickly run through this, right? So in the does anyone know how quicksort works? What's the step 1 of quicksort? Pick a
pivot element.
Pick a random pivot, right?
Yeah.
And then the step 2 is what? It's like
rearrange based on the pivot.
Shuffle, rearrange, basically, so that the left part is actually less than pivot. Then you have the pivot, and then you have the right part that is actually greater than or equal to pivot. Okay, so that's what you do, right? Then now let us assume.
But quicksort is also n log n, right?
Quicksort is n log n, not quick select. If you complete this entire operation, right, it's n log n. But here's the fun stuff. Let us assume that you somehow found out that pivot which is like magical golden, that divided your exact data set into n by 2 and n by 2 somehow. You're done, right?
Okay.
You don't have to go through the entire thought operation. It was just a O of n operation, you're done. Correct?
Yeah.
So case 1 is like golden,
Yeah, I know.
where you found the exact pivot. Okay. Then case 2 is where you found a pivot which is actually giving you a number that is like fewer than k. Okay,
Vivek.
Yeah.
Can you like please add like some extra spaces to the bottom, cause like I cannot like see.
Sorry.
Yeah. Thank you.
Got it. Okay. Thank you. So case 1 is so case 2 is where you have less than pivot, less than like your left side, right, has fewer elements than k. Okay, and then your case 3 is your so in case somebody's on chat, you can actually say, the free conference call, if you log in through the phone line, your carrier may charge you, but you can actually download the app and connect, or you can actually use the website. So if someone can just mention that on chat, that will be helpful. So you should be able to use the free conference call app, and that is free. And you can also use the website. That also works. So your phone company may charge, but whoever is trying to log in, ask them to use the website. And just use the headphone button there and use their computer, laptop speakers. Thank you, Mary. So you have this, right? So these are the 2. Now the thing is this. Let's assume that the left side has fewer than k elements. Okay. Then what you have done is that the problem is actually now simpler, right? Now you are trying to essentially find n minus k elements on the right side. And in this case, you're trying to find you already found. So in the quick select algorithm, the question will be something to the effect of find k elements that are smaller, that like find the k smallest elements, right? So given that you have like 100,000 elements, you need to find the smallest 1,000 elements. So what you do is that you shuffle, rearrange using the pivot. Now if you found the exact pivot that magically divided your set into the left size of 1,000 and the right size of the remaining, then you're good. That's case 1. Well, it wouldn't happen. The second scenario is that your left side, for whatever reason, you only found 500 elements, no more than 5, and the right side is all big. Then what you need to do is you just take the left side, and that is definitely all the elements in the left side are a part of the answer. So keep it aside. Now the remaining, whatever, 900,000, whatever, right, 999,500 elements, in that one, you need to find the 500 smallest element in that. That's case 2. Or case 3 is essentially when, let's assume that your pivot was found in such a way that you have 10,000 elements on the left side and the remaining on the right side, then you need to find 1,000 elements out of the 10,000 elements, and you just keep recursively repeating this operation. You get it. I'm kind of like mushing this in the interest of time, but there's a lot of interesting discussion on how to find, like how to actually figure out the kth largest element using quick select. That is algorithm, and that algorithm is actually, it's pretty sweet. Understanding quicksort is useful. Quick select, I think, has been asked in multiple different interviews in different flavors, and for many of the Leetcode questions, quick select is the answer as well. So it is definitely something for you to add to your things of, like, list of algorithms. If you know quicksort, quick select is just like one short stop away from that. Pretty good to have. All right, any questions? All right, jumping on to the third question. This one is actually quite insane. So let's figure out if there are people who can actually think about solving it. So essentially what you want to do is, given a string, your goal is essentially to figure out how to make it like match the string with a question mark or an asterisk. So let's do one thing at a time. Let's just do the question mark, right? So if I say SDE skills is the first input string, and I want you to match it to like SDE skills, right? It matches because it's pretty straightforward. It's a one-to-one substitution. This is very simple. Okay. Where it becomes harder is essentially I want you to match. So this is like somewhat like a regular expression, right? S star S. It should match this. So how do you do this? Any thoughts?
So Vivek, it will be all question marks in the first output.
No. This one actually matches, right? So it's not a. So this one is essentially saying that, like if I give you two strings, right? You're trying to implement like some kind of a match algorithm. So if I give you give me one second. Let me just add a few more lines in the end. Okay. So if I give you a string which is like say ABC, and I'm asking you to say, does ABC match ABC? The answer is yes. Are they equal?
Yeah. So we need to find the patterns, like, because if you have SDE skills and then in the second output it is mentioned as S star S, right? So that means there could be a word like shoes that also matches with S star S.
That is correct. So the question here is saying, does ABC match ABC? Answer is yes. Does ABC match A question mark C? Answer is yes.
Yeah, it is true.
Does ABC match A question mark B? The answer is no.
Oh, okay.
All right. Now, does ABC match A star C? The answer is yes.
Yes.
Does ABC match A star, like does A, B, 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 C, 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 does it match A star C? Yes.
Oh, okay.
Okay?
Okay.
So how do you figure out whether this pattern, the string matches the pattern? That's the question.
I guess a brute force way would be first check the length of each string. If they don't match, then you know they don't match.
No, but in this case the lengths are different.
So
it's a match.
Oh, I see. I guess you could also maybe have a double for loop. And compare each string to each other, and if it is a question mark or an asterisk, you would just increment to the next. You would just keep it at that that index until. Well, you'll check the neighbor. In this case, there's C, and then you would continue to stay at the asterisk until you either reach C or a different character altogether. But I don't know if there's a more efficient way.
No, but like, okay. So, do you think this will match?
Yes, it should.
Yes, it should match.
I believe like we can use a recursive solution.
This will match.
It would not match.
Yes.
It should match.
Wait.
It should match because this is the first star and this is the second star. It would have matched.
Oh, I thought you had a C and D there. So
yeah, there's a D, but the D will yes, it is. But this is the first star, right? You don't have to stop. Like when will you stop? You don't stop at the C. You could stop here. You may or may not. So this actually calls for a dynamic programming exercise. So how this works is, let's actually go back to the question and grab these letters.
Hey, Vivek, like, is there a way to solve it like recursive too?
Recursive is you will end up it'll end up being a dynamic programming in that question, in that case as well. How would it be recursive? Maybe?
Instead of creating a 2D array, I was just thinking maybe we can just match the first two characters if they are a match. If first two characters match, then we can say true plus true, and we need to match the remaining characters after that. If first
but they're being greedy. It may not work. Let's say the first character is asterisk. Now what do you do?
If first character is asterisk, then we take the input string and remove the first character from the input string, and then pass the same pattern, including the first star and the remaining string to see if it matches.
Yeah, so that would be the dynamic programming approach.
Yes, but I was thinking to write in a recursive way, so that's why I was asking.
You will write it in recursive way even for DP, except that you'll also memorize, right? That's all. So let's actually do this, right? So let's actually build a table. So the way this works is that you would, so I've taken the string, I've made it a little simpler, but I had to add more columns otherwise, and just write it this way, and then you would take the pattern that you want to match and put it here. Okay. So now this represents does it match or not between the string that ends with A from the left and the pattern that actually from the top. So essentially A and A will match, right? So far with me? Okay.
Yes, Vivek.
Does A match AB? No, 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 and no, right? This is easy. So A does not match A, B, 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 C, 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 D, B, C. It doesn't. So far with me? Okay. Does A star match A?
Yes.
Yeah.
Yep. Yeah. It matches A. Okay. Does A star match AB?
Yes.
Okay. Does A star match ABB?
Yeah, it matches all.
Okay.
Yeah.
So once since it's a star, it will basically only time this will, so we'll get to that. We'll get to the next one. Now, does A star B match A?
No.
No, right? So false. Now, does A star B match B?
Yes.
It's only true if, oh actually I missed this. I should have added this. Insert one above and insert one to the left, because this is essentially empty, right? And this is empty. And empty matches empty, that is true. And empty does not match anything. This is false. And false, and false, and false, and false, and false. So this is the basic one, right? Okay. So now, how this works is that, so now, in order for this element to, what will be the value of this element, right? This element will be true if B is the same as this B, right? If this character, the pattern that you're looking at is the same as the pattern that you're looking at here, then this value will directly depend on this value. So this will be true. And it's true because of this.
Okay, so we are essentially checking here if we remove the B from the both input string and the pattern, then we are left with A star and A, so that matches.
Correct. Only if A star and A match, then A star B and AB will match. That we know, right? So far with me?
Sure.
Okay. Now here's the thing. What about this one? Is it true or not? This is true only if this diagonal thing is true.
True.
Is this diagonal thing true? Yeah.
True. True. Yeah.
So this is true. This is true.
True.
What about this one?
False.
False. What about this one? False. What about this one?
True.
True. What about this one?
False.
This is false because even though diagonal is true, this B is not equal to C, right?
Yeah.
This B is not equal to the C, so it's false. Done. Now what about the next one? So now if it's asterisk, then what does that mean?
It's true.
No, it's true only if the one above is true.
Yeah.
No, if it's a star, then the one above has to be true.
Oh.
Since above is false, this is false. Okay? What about this one?
False.
Since it should be true. A star B matches AB, right?
Okay.
A star B matches AB. So A star B star must match AB as well.
Yeah.
This is true. This is true. This is
false.
True.
How is this true?
And this is true because like the first characters are matching, and then we can take the second B as like the star, like second and third B as the star, and then the fourth, like the third B as again B, and then C as an star.
No, so what? It's just like the rule that I said earlier was that if the above line is true, then the below line is automatically true. That's what we said, right? For a star. Okay. The other exception to this one is that if the element to the left is true, then also this is true. Either this or this has to be, one of them has to be true for this one to be true. So in this case, is it true?
Yes.
So you're good, right?
Yeah, everything else should be true then.
Okay, so let me just get rid of this. Okay, what about this one? So this is false.
False.
What about this one? False. This one false. This one false. This one? It only depends on this.
True.
Right?
True.
So this is true. What about this one?
False.
False.
False. False. What about this one?
True.
True.
Because it depends on this. Right?
Yes.
What about this one?
True.
Because it depends on this one. Right? And what about this one?
True.
Also true, right? Because this one actually depends upon this one. That's why it's true. Right? And so A star B star C actually matches A B B B C D B C C. Right? How about that? That's simple? Not really?
Not really.
But does it logically make sense? Like forgetting, like, how would you derive this in an interview? Let's come back to that. But does this logic make sense? Like, are you able to actually figure out the wildcard matching? Now we missed one more thing here, was essentially saying that we should have figured out what if I add a question mark, right? How does it work if I add a question mark?
It should be the same as the diagonal one.
Except that you don't have to check. You don't have to have these two as equal. So this is false. 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 This is also false. This one is true.
Yeah.
Because D will match the question mark. Okay. And this is true. And this is true. This is false, right? I mean, that's it, right? This makes sense? This one is false. Why is this one false?
Because the diagonal one is false.
Yeah, because diagonal one is false, which means that if you let the last question mark match the C, then you will not be able to match the previous C, like if you go from the back, right? Okay. So now the question is like, how do you figure this out? So before I go into that side of the question, let's take a step back. Anyone who does not follow this dynamic programming table, drawing this table, just for this question, if I ask you to repeat this question, repeat the answer, would you be able to do that?
I didn't understand. the when do we take the diagonal versus the left top portion? Like in the star, do we do that?
Okay, so let's actually take this one example, right? Let me just mark it as something. Okay, so this thing which I've marked as blue, right? What does that mean? That means that a match of string ABB and A star is true. That's what that means.
Yeah.
Okay, so what I'm saying is that so that so far makes sense.
Yeah.
Okay, now the question is, I'm trying to find out. Let me pick a different one, and I want to call it make it like red. So I want to find out if this is true. What this thing there, right? I don't know the answer to this. I'm going to delete this. Okay. So you are trying to find out what is the match of A B B B C and A star B star C. This is what you're trying to figure out. Okay. You don't know that, but what we know is that this is true. That we know, right? That's the blue one to the top left of this. Correct?
Yeah.
If this is true, then what we also know is that this followed by any character and the same character is also true. Correct?
Yeah, got it. Okay.
Which means this has to be true. Correct? So when you have the same character here, right? Let me fill this with a different color. If you have the same character here and here, right? Then the corresponding value here will be essentially whatever is the value that is the diagonal of this one. Right?
Got it. Okay.
Okay. That makes sense.
Yeah.
What about if you have if you have a star? If you have a star, let's do that, right? So match of, let's assume that you have a string which is like string, okay, and pattern. Okay, if I know that this is true, okay, then match of pattern and a star is true. Is that correct? And what is that? That is one above, right?
Yeah.
Correct?
Yeah. Yes.
And at the same time, so when and the other one, of course, is that if I know that the pattern star is true for a string, then string X will also be true for pattern star. Like adding a letter at the end of the string will also match pattern star.
Yeah, that's true.
Right. So that's how you go from left. So either if in order for the starred thing to be true, you have to check both the left guy and the one on top. So in order for this one to be true, you have to check this or this, both. Either of them should be true. And in this case, it so happens that the one on top is true. That's why you made this true.
Yeah.
Okay. So far with me?
Yeah.
All right, awesome. Anybody else having trouble understanding this table?
Vivek, what about the first star row? How that is computed? Because
the very first one?
No, the row number 5. Row number 5. So there you you don't have that star, right? Meaning, how do you start with? There you don't have anything to compare.
That's correct. So empty with A star is false. We know that.
Okay. Yeah.
Empty with A star is false.
False.
A with A star is also is true. A with A star is true because A matches A. That's why it's true. So this true. actually depends on either this
or the left one. Okay.
And one of them is true. The one on top is true. That's why this was true.
Okay.
Right?
Right. So okay. So because it was true, that is why. Oh, okay. Understood. So that's why it got the rest of them as true, based on the matching, pattern matching. Okay.
Correct.
Got it.
Okay.
Okay. Thank you.
So makes sense, right? So yeah. So now that we know this concept, right? So this sort of drawing a table and essentially trying to figure out the relationship is a very common pattern that happens in dynamic programming. So essentially what you're trying to figure out is that you're trying to essentially look at a sub problem, and if you are able to solve for, like, essentially this is like str a followed by a x followed by a x, and you have like the other one is like a str b followed with a y. You have rules around, like, a not b, b not a, or something, and then you have figured out in this example what we have said is that if this is true, then this has to be true. If this is true, then this has to be true, and you've kind of drawn the truth table based on that, right? And essentially what Gaurav was saying earlier as a recursion process was saying that in order for me to make sure that I can match this, I need to just make sure that if the last character is a question mark and this is a question mark, then all I'm going to check is I'm going to check if this works, and that's it. So I'm going to recursively call this. Now, if these two characters are different, then I can just get out, because if this were false, then this would be false and I'm done, right? But if not, then what do I need to do? I need to go further and then, like, double check with this. Now, in order for C and C, this needs to be true. If this were to be false, then you're done. But you need to go further in. Now, how do you, once you find an asterisk, that's where you have a problem. Because now a star can represent everything. It can represent 1, 2, or multiple things. So then you have to essentially figure out both this value and this value in order for you to determine this one, which is exactly what we did in this table in the tabular form. You will end up computing the exact same values, Gaurav, if you do it this way.
So Vivek, if we have something like star A as a pattern, then the first row will be true, right? If it starts with.
Let's find out. So let's say if it was star A. Okay.
Okay.
Let's do that. Let's actually use this as an exercise. So the first column, this is easy, right? So this is false.
Yeah,
false.
this is
That's what we know.
Yeah.
Right?
Yeah.
Okay. So what do you think? What do you think is this one? Does star match A?
Yeah, a star means anything, so it is true.
Actually, no. This is not false. Does star match empty?
No, it's false.
Of course it does. No, of course the star match is empty. Star means 0 or multiple matches.
Okay. Oh, 0 or multiple matches. Okay.
Star match is empty, right?
Yeah.
Okay. So then does star match A?
Yeah. Yeah. It could be true, right? Because it could be any character. So the whole.
In order for you to match this thing, which I'm going to mark with this green, one of these two
should be
one of the two blue squares should be true. Are they true? Is any of them true?
Yes.
Of course. So which means that this is true.
True.
In order for this guy to be true, what do you need to do? One of these two must be true.
Yeah, top and left should be true.
So that is true. So this is true. This is true, right?
Yeah.
Star matches everything.
Yes.
Correct?
Yes.
Okay. Now, in order for does A match empty? No. False.
No. False.
Does A match A? Star A match A?
Star A matches A. It has A. True.
Oh, no. Only if this is diagonal, right? There's a diagonal relationship. Only if star matches empty will star A match A.
A is matching A, so we just take the diagonal one.
The diagonal, right? That's why it's based on the blue T. 4B, right? Column B 4, row 4. Column C, row 5 is true if and only if column B, row 4 is true.
Okay.
Correct?
Okay. Yeah.
Since A does not match anything else, so these things are all false.
Oh yeah. Yeah.
That's it. So star A does not match A, B, 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 C, D, B, C, C, but it matches.
It matches star A.
It matches star A will match just A.
Just
Correct.
A. Okay.
Correct.
So that
Now,
means if it is letters, then we have to just look for the diagonally opposite ones. But if it is star, we will look at whether which one of the columns to the left and to the top are true. One of them.
Yeah, but don't think of it that. I mean, that's good. That's a good summary, but that is because of how we define these rules, right? If string pattern is true, then string pattern star is also true.
Star is also true.
Right?
Yeah.
That is why you are looking at the one above.
One above. Okay.
Right. So, like essentially, what you're saying is that if you know this condition, right, then you know that string X and pattern X is also true. That is why you go diagonal.
Oh yeah, yeah.
If X equal to X, if the letters match, that's why, right? And you also know that essentially string X and pattern Y is false, right?
Yeah, it is false. That's right.
Hey Vivek.
Yeah.
Yeah. What would be the rule with a question mark?
What would be the rule for question mark? What do you think?
It should be same as the character match.
Except that you don't have to. It's not this, right? So essentially, it's the same condition that we had here. Let me actually let's justify this. It's messing with my thought process. Okay. Okay. So if this matched, then string X pattern question mark is also true, right? Correct?
Yes.
That's all you're matching. So it's the same as this. It's the same as your A match, but essentially in this case, if I had a question mark here, right, then all of this will be true because you only look at the diagonal. Correct.
Okay.
Without having to compare the question mark and the A question mark and the B and so on, right? Okay.
Yeah. Thanks.
Okay. Any questions? Now we are like a couple of minutes over. So what I'll do is I'll just stop here. Writing code for this is actually going to be painful, but this is just more of an introduction to one of the types of dynamic programming questions. This is like you would use this for things like edit distance and a whole bunch of other questions which actually follow a similar pattern. But again, it's definitely something. This is not one of those programming interviews easy sessions, but it's just something for us to think through. So what I'll do is I'm going to stop the recording here, but I'll be available for chat for another like 10 or 15 minutes in case folks want to discuss.